So this is the 2016 Cert Ordinary Level Paper 1 and we're looking at question number 7. Paul has €8,000 that he wants to invest for a maximum of 3 years. His local bank is offering him two options, option 1 and option 2, as shown in the table below. So option 1, he gets 2% interest in year 1, 3% interest in year 2 and 5% in year 3. And his money can be taken out at the end of year 1 or year 2 without penalty. Option 2 then, he gets 3.7% compound interest per year for 3 years. And with option 2, his money may not be taken out until the end of year 3. Okay, so part A says, find the value of the investment at the end of 3 years if Paul chooses option 1 and does not take out any money. Okay, well, if he has £8,000 to begin with, so 8,000, if he puts that in for the first year, if he gets 2% for year 1, so for the first year he's going to multiply it, add 2% to 100, that's 102, and write that as a decimal, so 1.02 he's going to multiply it by. And then whatever the answer to that is, you're going to times it by 1.03 for the second year. And whatever the answer to all this is, you're going to multiply it by 1.05 for the third year. So you can just do it all in one go like this. So when we put this in the calculator, we get 8825.04. And that's euro. So that's the value of his investment at the end of 3 years with option 1. Okay, part B says find the value of the investment at the end of 3 years if Paul chooses option 2. Okay, so with option 2, he puts his £8,000 in. Let's have a look again. It's 3.7% compound interest. So 3.7%, if we add that to 100, that's 103.7. 103.7 as a decimal is 1.037, but that's for 3 years compound, so it's by itself 3 times. So we put that in the calculator. That gives us 8921.261 and on it goes, but because it's money, we're going to say 8921.26 euro to the nearest cent. Okay, so that's option 2. Part C says give one issue other than the rate of interest earned that Paul might take into account when deciding between option 1 and 2. So if we go back and have a look, well, one issue might be the fact that you can't take money out with option 2 until the end, so maybe he'd want the flexibility to be able to do that. That might be something to consider. So we can say the flexibility or the ability to withdraw before the end. So something like that for your answer would get full marks. Okay, part D. Paul would like his investment of £8,000 to amount to £9,000 after 3 years. What annual rate of compound interest would be required for this to happen? Give your answer as a percentage. Okay, so you can see down here, I've taken this from the tables book. The compound interest, well, the final value is equal to, this was the formula we used earlier, but the final value, which is £9,000, that's F, will be equal to the principal, which is £8,000, times 1 plus I is the interest rate that we're looking for, and T is the number of years, so 3 years. trying to find the interest rate, the annual rate of compound interest for this to happen. Okay, so the first thing we could do is divide both sides by 8 grand, because we want to isolate I ultimately. So we divide both sides by 8 grand. The 8 grands cancel here, and here we're left with the zeros cancel, so we're left with 9 over 8. That fraction simplifies to 9 over 8. So 9 over 8 is equal to 1 plus I to the power of 3. Okay, so we want to get rid of this cube, so we're going to cube root both sides. So we can say the cube root of 9 over 8 is equal to 1 plus I. And then we're nearly there, we nearly have I on its own, so all we need to do now is move this 1 over here, and it'll become a negative 1. So what we have then is we've got on the right side here, we've got I. I'm just going to switch it to the left. So I is equal to the cube root of 9 over 8 minus 1. And if we do this in our calculator, that gives us a value of 0.040, and on it goes. So that's the interest rate as a decimal, but we want it as a percentage, so we're just going to times that by 100. So we can say that the rate is this times 100, which is about 4%. Okay, moving on. Part E says another bank offers to invest his 8 grand in a special fund. The bank has found that in the short term, the amount of money in this fund follows the formula V is equal to 8,000 plus 36t minus 1.2t squared, where V is the value of the fund in euro and t is the time in months since the 8 grand or the 8,000 euro was invested. So find the value of the money in the fund after 12 months. Okay, so 12 months, that means that t will be 12. So the value of the money, that's V, which will be 8,000 plus 36 by t, which is 12. Minus 1.2 by t, which is 12 squared. So when we put all that in the calculator, that gives us a value of V equal to 8,259.2. And because this is in euro, we can say that's 0.20 for 20 cents. So that's the final value of the fund. Okay, and finally, E part 2 reads, Mary invests 8 grand for 1 year at R% per annum. After 1 year, her investment is worth the same amount as the answer to part E1 above. So that's this answer here. Find the value of R correct to 2 decimal places. Okay, so basically we're putting 8 grand into, we're going to invest it for 1 year at some percent, and it's going to give us this, and we want to know what that percentage is. Okay, so, well, first of all, what we could do is we could find the interest that was earned in the year. So if it goes from 8 grand to here, the interest will be equal to 8259.20 minus the 8 grand. So that gives us the interest, which is 259.20. That's the interest. So we want to know What's that as a percentage of the original amount? So all we do then is we write that 259.20 as a fraction of the original, which was 8 grand. And we're going to times it by 100 to turn it into a percentage. So when we put all this in the calculator, 259.2 over 8,000 times 100, and that gives us 3.24%. So that's the interest rate. So this is the rate, and that was the interest in money. And that's the end of the question.